Imagine an aircraft engine producing over 3,500 horsepower. Without liquid cooling, it would instantly destroy itself. The Napier Sabre solved this problem, but created several new ones. Unlike ordinary V12 engines, the Sabre used an H24 configuration. Think of it as two flat 12 engines stacked together, sharing one crankshaft through gears. This allowed an enormous number of cylinders, while keeping the engine surprisingly short. More cylinders meant smoother torque and the ability to spin faster. Instead of poppet valves, the Sabre used sleeve valves. Each cylinder had a moving sleeve with ports cut into it. As the sleeve rotated and moved up and down, the ports lined up perfectly. This created huge openings for airflow. More air meant more fuel. More fuel meant more power. Poppet valves bounce at very high RPM. Sleeve valves don't. This allowed the Sabre to exceed 3,800 RPM, extraordinary for such a huge engine. Less valve float meant more stable combustion. Higher RPM normally increases stress. The sleeve valve delayed that limit. As altitude increases, air density falls. Less oxygen means less power. The Sabre solved this using a two-speed supercharger. The compressor squeezed more oxygen into every cylinder. Increasing pressure packs more oxygen molecules into the same volume. Producing over 3,000 horsepower also produced enormous heat. The Sabre relied on liquid cooling. Coolant absorbed heat inside the engine before carrying it to the radiator. The coolant's large heat capacity allowed it to carry away thermal energy. The Sabre's sleeve valves required incredible precision. The sleeves had to rotate, move vertically, and seal combustion pressure. Early manufacturing tolerances weren't good enough. Tiny errors caused catastrophic failures. Once engineers solved these problems, the Sabre became one of the most powerful piston engines ever installed in a fighter. It powered the legendary Hawker Typhoon and Hawker Tempest, giving them exceptional low-altitude speed and acceleration. The Napier Sabre became legendary because engineers pushed physics to its limits, using sleeve valves, supercharging, and precision machining.